Hi everyone. So in this video we will start non-deterministic finite automata. So in the starting videos I told you finite automata is classified into two categories. One category is finite automata with output and the next category is finite automata without output. In finite automata without output we already learned deterministic finite automata. But the next part which we will learn is non-deterministic finite automata. So today we will discuss non-deterministic finite automata. So let's see the definition first. In non-deterministic finite automata, the non-deterministic finite automata means it is a non-deterministic machine, and non-deterministic machine can take any moves for a given input alphabet. Okay, in our real life non-deterministic machine is not possible, but we will study non-deterministic machine because of simulation process. So in simulation we generally take some input alphabet and take some non-deterministic machine and try to visualize that what happens if we take some random inputs for the some random state. Okay, and if we get the better result, then we will apply this particular simulation in our real machine, which is deterministic machine. Okay, so non-deterministic finite automata will also contain 5 tuples similar to deterministic finite automata. It will contain capital Q, sigma, Q naught, delta and capital F. Okay, here you already know capital Q is where capital Q is finite set of states. Finite set of states. Just for the completion process, I will take all the symbols here. Sigma, you must be knowing that sigma is input alphabet, then Q naught is initial state, delta is transition function, okay, and capital F, which is final state. If I get same number of tuples and same tuples in the non-deterministic finite automata, then what is the difference? What is the difference between DFA and NDFA in theory? So the main difference is the transition function. In DFA, if you remember, if in DFA the transition function will Q cross sigma tends to Q. This is the transition function. But in NDFA, the transition function is Q cross sigma to 2 raised to the power Q. Okay, this is the transition function for NDFA and this is the transition function for DFA, and it will make much more difference. It will make much more sense in NDFA and DFA. Final state will remain as it is. Final state will always a subset of the finite set of states. Okay, so let's take an example. Example will clear your doubts. Let's say I have a language ends with A, and here also in NDFA concept you will assume that the input alphabet is A comma B. If I draw the non-deterministic finite automation machine, that means transition diagram for this language, so the NDFA will look like this: capital A, initial state, any number of A's or B, and then if I see A, that means it ends with B, and I will simply accept the string. That's all it. So here if you see the transition diagram, first of all on capital A, if I see A, then I will go to two different states. One is the capital A itself and second one is the capital B. So this is the main difference coming to the non-deterministic machine. Non-deterministic machine take any number of moves for a given input. Okay, and on capital B, if you see that capital B does not have moves for input alphabet A or B because it does not bother much. The main concern here is the string which always ends with A, and string ends with A, I will go to the final state. So let's say I have take some string. Let's say I have string A and here I have a string A B B. Okay. So if you trace this particular string on the transition diagram, then capital A seeing A will go to two states, capital A and capital B, and you already know that capital B is the final state. That means this particular string is accepted. This is accepted by our non-deterministic machine. On the other side, if you take this particular string A B B, capital A on small a will go to the capital A and capital B. Now on capital A, if you see B, you will remain as it is in capital A itself, and on capital B will does not have any move for the input alphabet A and B. So here I will use a special symbol phi which denotes the dead configuration. So in deterministic finite automata machine, DFA will have a concept of dead state. Dead state means you simply reject the string which is not present in the language. But in non-deterministic machine have the concept dead configuration. Dead configuration means there is no any move defined for such input alphabet. Okay, for such string. Here also on small b you will go to the capital A state itself, and if you see the final capital A here and phi, both are non-final states. Phi is a dead configuration, so we cannot consider them as a state, but capital A is not a final state. That means this particular string is not accepted. This particular string is not accepted. So you understood it, how we draw the transition diagram and trace the particular string on this NDFA. Now let's visualize how the transition function in transition and non-deterministic finite automation machine will look like. So for this transition diagram and for NDFA, if let's say I have total two states A, B. Okay, here I have two states A and B, which is Q cross sigma. So Q cross sigma means capital A seeing is input small a, capital A seeing input small b. Similarly, capital B is seeing input small a and capital B is seeing input small b. So there are four different possibilities, and it will go to the 2 raised to the power q. 2 raised to the power q means if you have two states means 2 power 2. So how many states possible? Total 4 states possible. That means I will take state A, state B, state AB and then phi. So there are total 4 different states possible in the non-deterministic machine. On capital A, if you see small a, you will go to the state capital A and as well as capital B. If small b is your input, then you will go to the state capital A itself. And what about the small a and small b for capital B state? It is not defined. let's say you will take here 5, 8. Okay, so here it is not going to, it is going to, let's say AB. No, see, it is not this way. A on A, it is this. Okay, and capital B on A. Yeah, that is the transition function. So if you observe in that non-deterministic finite automata, we have various possibility for any for a state which have some input alphabets. So if you compare the transition function of non-deterministic and deterministic finite automata, you will see that every deterministic finite automata machine is non-deterministic finite automata.